So hopefully before you started this video, you spent a little time with this problem up here at the top. If you have not yet tried thinking through this problem, please pause this video and answer the question. It says to use any strategy to determine the area of the shape below. So you see this kind of outlined, funky looking shape, and I just want to see what you can come up with for the area. So if you haven't jot any thoughts down or gotten an answer yet, go ahead and pause this video. If you have, hopefully we can just talk about your strategies. I'm not really sure what your plan of attack was. Maybe because this isn't a shape that we have a formula for, you just counted all of the little squares, and that is an awesome response. That's using tools that you know, just skills and strategies that you know, to get to an answer. My goal today is just to show you a little shortcut, because there won't always be this nice pretty grid behind the shape. And we need to have some strategies for what to do if there's not. So I think the biggest strategy that I can share with you, because we do not have a formula for this shape, is to split it into shapes that we do have formulas for. So I'm just going to show you one possibility of how you could have gone about splitting this and using just the numbers on the outside to help you get an answer. So I can cut this. If I make a cut right here, and I'm going to use a color here so you see my cut. If I make a line right here, I have one rectangle right here. And I know the dimensions of this rectangle, so if this grid wasn't here, I would be able to take my 7 and my 3 and multiply them together to get 21 for the area of that rectangle. I could also do the same thing on this side. And again, if I didn't have this nice pretty grid behind it, I could make this rectangle here and see that it was a 3 by 6, and therefore this shape was 18. And that just leaves us then with our little tiny piece here in the center, which is really easy to see that it's 6 at the moment. But again, if that grid wasn't there, I just want to point out that really the only dimension we have at the moment is that it is a cross of 3. And if I look around the other parts of this shape, I see that this whole side is 6, and I see all the way down here is 7, but there really isn't any indicators of what this height could be. So unfortunately, this split that I just walked through wouldn't really work. And that's a possibility. Sometimes when you start splitting up a shape, you won't be able to split it the first way you try because you don't have enough information to determine a dimension. And that's what we just ran into here. I just want to encourage you not to stop and get frustrated, but rather try again. Erase the shape and maybe try splitting it up in a different way. And so I'm going to model what that might look like now if my eraser is going to work. Just maybe a different way that we could have split it up to help us get that final answer again without the grid. So what if instead of that way, I tried splitting it this way, and I split it to be a nice little rectangle up on top. Then I notice that I don't have this dimension all the way across the top again because we have the grid, we could find it. But this is where just manipulating and using information around you might be able to help. And I see that there's a 3 all the way at the bottom that would represent this piece. There's another 3 here, and yet another 3 that I could bring up here. So I know that that distance all the way across is 9. Notice how I just had to kind of move some numbers around to get that. And I still don't quite know what the height of this shape is, but I do know that this whole side here is 7, and that this whole side is only 5. So that leads me to believe that this missing distance from the 5 to get up here would then be 2 to get my total distance of 7. So again, some of this causes some manipulation, just using the clues around you. And it just really needs some endurance on your part to really kind of put this puzzle together. So I'm not going to walk through this entire example, because we know that this one was 21, this is 18 plus 6 were my missing pieces. So hopefully you arrived at a conclusion of 45 centimeters squared for this shape. But of course we have to jump into a couple examples that aren't as simple. So below this you see a shape that looks like this, and right above it it says, what's the best way to find the area of a complex figure? And I just want you to fill that in by saying split it into shapes you know. That will make a complex figure a little more simple if you can see shapes that you already know. So this example, you can see that they already did that for you. They gave you this shape right here. They put this little dotted line. Hopefully that's starting to stick out to you as a trapezoid. And then they split this shape over here. Hopefully you are using those context clues, seeing all those 19s to see that that's a square. So really we have two different shapes. If we find the area of each of those individually, you can add them together and get your total area. I'm not actually going to walk through this one with you. I want you to come back and do this one, but I want to do one of the more difficult ones on the back with you just as another example of manipulation. So you see this example up here at the top, that again the grid's not there. It's not just a perfect rectangle, but rather it's a couple different shapes pieced together. So we're going to have to use that strategy of splitting the shape into something we know. So maybe you're seeing the shape differently than me, but I'm going to make a cut right here to make two different rectangles. So I'm going to have this rectangle up here in blue, and then I'm going to have another rectangle down here, hopefully in a different color, yep, in red. So those will be my two different rectangles, and hopefully we have enough information to find those areas. I'm going to start with the blue one because that's a little more straightforward. We have a base and a height of 30 by 5, and it's so awesome when they give that to you that simply, because then we can just kind of quickly arrive at our answer, and it's 150 millimeters squared for that blue rectangle. And maybe you're wondering, Mrs. Reiner, what about this 20? Because that's labeling part of this rectangle, and it is, but it's really only labeling this segment of the rectangle. So we have to use that 30 that's going all the way across. But then we're running into this problem with our red rectangle, because all they gave us, and again, hopefully the red's going to come up here, all they gave us is a 7 centimeters. So we know the distance going up and down, but we're not quite sure what this distance is. So that's where our manipulation comes into play, and I have to read the other lines on the shape. So I would start by looking at lines going in this direction from left to right, because those are the lines that are going to help us get our clues. So I see the other lines going in this direction are this 20 up top and the 30 again are both my two lines going in that direction. 30 is my distance all the way across, while 20 is the distance just from the start of my red rectangle to the other edge. So hopefully you're seeing that there's something I need to add to this 20 to fill the rest of the space to get to 30, and that's how we found that missing measurement of 10. So this other rectangle is then a 7 by 10 rectangle, which is 70 millimeters squared. But the question wasn't to split this up and find two different areas, but rather what is the area of the entire shape. So the last thing we need to do is add our two shapes that we split together into one. So we have the blue is 150 plus the 70 of the red shape, and we get the total area is 220 millimeters squared. So this is a little more complex than just looking at our formula sheet and identifying shapes, but rather you get some creativity into splitting it up. There's another way you could have split this shape, and so maybe you and I are going to differ just in how we see things, and that's the cool part about our geometry here. So I want you to start by going back to the front of this paper and working through that first example we skipped over. Start there because they already did the splitting for you. So find the area of that trapezoid and then the area of the square, and then add those together. And then once you've got that answer, then I want you to try the second example down here at the bottom of this page. See how you split that and get your area, and then come back and see if your answers match mine. So pause the video, just do those two, not that last one yet, and come back and check in with my answers. So hopefully you came back and started with this. I got the area of my trapezoid with my two bases added together times my height times 1/2 to be 486. And then that square was 19 by 19, which was 361. So when I added them together, I got 847 meters squared. If you didn't get this, please pause the video now and just kind of compare your work to mine and see maybe where you went wrong. Otherwise, turn it over to the back, and we got this other example. I split this into a rectangle and then a trapezoid. So the rectangle was pretty straightforward. We had an 8 by 10 here in blue, which was 80 centimeters squared. That trapezoid I outlined just so my eyes could see it better, and I brought that 10 over to be my other base. But I had to do a little manipulating to get this 4, because I knew this whole distance was 12. And down here, the other line going from left to right was only 8. So that difference was 4. And again, this trapezoid's tilted on its side. So 4 is the height. So I got the trapezoid is 34 centimeters squared. So together, that's 114 centimeters squared. So again, pause if you didn't get this. Maybe look around and see what you did different to me. Otherwise, we're going to move into that last example down below, which is a little bit different, because this question says to find the area of the shaded region only. So hopefully you see that we have two rectangles. I see this outer rectangle, which is an 11 by 8. So I'm going to start there, but just by finding that 11 by 8 rectangle, base times height, gets me 88 inches squared. But then I have a inner rectangle that I see is a 9 by 6. 9 times 6, base times height, gets me 54 inches squared. And unfortunately, at this point, I haven't found the area of just this shaded region, because that 11 by 8 is the entire thing filled in, and then really we have this white rectangle punched out of the bigger rectangle. So if you're going to take that space away or punch it out or cut it out, that's representing subtraction. So you do have to find the area of both of them and subtract the two to find your overall area of just that shaded kind of donut piece. So 88, if we subtract 54, we get an area of 34 inches squared for the shaded region only. So that brings us to the end of this assignment. Move forward in your Schoology agenda for further instructions.